Welcome to Analyst Crossfire, an HPCC 2012 wrap-up show featuring expert voices from the supercomputing community, giving their reactions to some of the top HPC trends as discussed at this year's conference. I'm Addison Snell with Intersect360 Research, and I'm your moderator for Analyst Crossfire. Joining me on the panel today are 4 members of the HPC community, 2 from technology vendors and 2 representing HPC users who have volunteered to share their opinions on the supercomputing topics I've chosen, giving us their personal views and not necessarily those of their organizations. Representing the HPC vendor community, first we have Marc Fernandez, who's an HPC computer scientist at Dell. Good morning, Marc.
Morning.
Next we have Marc Hamilton, who's the Vice President of HPC for HP. Marc, thanks for joining us.
Good morning.
From the supercomputing user community, we have 2 highly esteemed personalities, well recognized for their strong opinions. First, Steve Finn with Cherokee Information Systems. Welcome, Steve.
Hi, Addison.
And finally, someone who's intimately familiar with both supercomputing at the highest scale and digital manufacturing adoption at the entry level, Merle Giles from NCSA. Merle, thanks for joining us.
Good morning, Addison.
Panelists, thank you for joining me for a HPC 2012 edition of Analyst Crossfire. The clock is running. Let's get started. Our first topic today looks at digital manufacturing and the advanced technology gap that separates large and small manufacturers. Numerous programs, consortia, industry groups, and vendor initiatives have targeted what the U.S. Council on Competitiveness calls the missing middle. Panelists, how significant is this opportunity for HPC technology vendors and for the country, and where are programs succeeding or failing? Merle, I want to start with you.
Appreciate the opportunity. The several good programs going on. The dialogue is appropriate. Endemic is a little underappreciated. Appreciate you opening the door for me on that yesterday. But
it's been underappreciated by me specifically, and I wanted to give you a chance to hit back.
And by many, because we don't tell the story as well, perhaps, as we do it. But what Endemic arguably does is hands-on work, one-on-one, with real power users at the low-end scale, at the SME community. And they have issues of this power usage, the physics, how they push this that actually are as difficult as what some of the larger companies do. And that's been maybe the most surprising thing, is that the work is real, the work is tough, but there are solutions out there. So the access, the business model kind of stinks, and that's what we help them with, is actually get through and show them a way to actually get the high-end, very advanced modeling and simulation done. And that's been fun. And as a large center, why do we care about the small ones? We care because it's not just serving small companies, it's actually a supply chain play. Mm-hmm. It's not just an SME play, it's a supply chain play. And that's been fun. A
lot of my criticism of Endemic came from my perception that it was primarily helping people who'd already adopted HPC and not necessarily people who hadn't done it before.
2 examples. One that had 4 and 8 core adoption and now can do 192 cores, and we're pushing that a little bit more. Another company that had never adopted at all was doing the old world stuff with hydraulics, and now they're able to differentiate between which product is best by just a little bit of modeling and simulation.
Steve, what do you think? Is Merle pulling my chain here? Is this good work?
This is good work. It's kind of out of my field because most of my customers are government, both large and small business. There's not much of a gap because we have ready access to DoD HPC mod program systems. Hardware is not a problem. Software is a problem because at the very high end of the top 500, you've got national labs, you've got the NCSA prac teams. They've got frameworks. They can use libraries and runtimes and all that. Anywhere below the top of the top, you've got less motivation or resources for doing all the modern things to your software. If it runs, you get a good answer, close enough.
Well, Marc Hamilton, I mean, this is important to HP and to Dell as well. I'll get to you, Marc, in a second. But, you know, you're trying to find a way to sell more servers here. So what do you think of these programs?
So I love anything that has initiative in it or program, because inevitably I get invited to a bunch of conference calls that are really boring, and it's a chance to catch up on email. But that being said, I think...
That's not the Alliance for High Performance Digital Manufacturing you're talking about, is it?
No, that's just some of the government ones. But I think that a lot of times you get, HP and Intel, or pick any two vendors in the room, and they have a profit motive, and that profit motive isn't necessarily aligned with the initiative. With Missing Middle, I think...
It's also not necessarily aligned to it being a U.S. initiative. You don't care where in the world you're selling.
Well, we're a global company, so that's true, and I think we'll address that later. I think the right model, I love the X-Prize model, right? I think we should look at models like that for some of the Missing Middle initiatives and let capitalism play out.
So you're going to let the government butt out and just go let mercenary capitalism do its work here. What do you think, Marc?
Yeah, I agree. I'm very excited that you mentioned supply chain. Dell knows a little bit about supply chain and supply chain management. Generally, the attention has been on the actual manufacturing of something once all the supplies have arrived. Well, in fact, every member of the supply chain is a small manufacturer. And so I believe attacking the larger manufacturers and their supply chain of small, medium manufacturers is the way to go. And Dell does that in its day-to-day business, and we're transitioning that into a sales opportunity.
Well, are we on the right track? What more ought to be done here, Merle?
We've learned a couple things early on in this endemic project, just as one example. A, we had improper assumptions about what the ISVs really do. With them in the room side by side, we're learning about what their strengths are and so forth. We also didn't quite understand what the SMEs do. They do far more and far more capable than we thought they were. They're not just players on a PC. Mm-hmm. Also, we had improper assumptions of the OEMs, actually the large companies. They didn't know what their supply chain was actually doing in terms of digital modeling. Mm-hmm. Now a few of them do. We also need to be able to play nice together and be more collaborative in the delivery, in the business model, not just the modeling and simulation, not the tech side, but the business model. And this public-private partnership that has money from government and from industry gets the attention of all the people at the seat who sit at the table, and they've not had that dialogue before. But the most surprising thing was how the OEMs have learned what their own supply chain is doing or not doing or can do, and without that initiative, they weren't asking.
Mm-hmm. I'm not exactly sure what you're asking for there. But for U.S.-specific initiatives, I particularly think Digital Manufacturing Strategic Interest Group and the accompanying PIC strategy out of NCMS, the National Center for Manufacturing Sciences, has a pretty good chance for success. I personally haven't seen a whole lot of great programs out of the government yet, but if they want to be involved, I wouldn't mind seeing them subsidizing some more industry academic partnerships here. Thank you, panel. Second topic today looks at the relationship between HPC, which is often viewed as a niche market for technology, and the broader enterprise data center market. We often see technology transfer and even the same products sold into both HPC and non-HPC data center markets. The question is, where are the most important overlaps from a technology perspective, and what significant technologies can HPC reap from the non-HPC data center? Marc Hamilton, I'm going to start with you.
I think it's all the other way around. We see the enterprise market and our enterprise products reaping benefits from the HPC market. One of the areas we think is specifically important is in power and cooling technologies. Or you walk into any data center around the world, and even if they have room, they typically don't have more power and they can't cool the system. So I think that's one of the very interesting ways. One of the ways that we flow back into HPC is actually not from the enterprise, but from the gaming market. If you look at things like GPUs from NVIDIA, 90% of their GPUs go into gaming, and that's been a huge benefit back up into HPC and server-based GPUs for computation.
The new Kepler GPUs were just launched last week, and we're expecting them for HPC by the end of the year. Marc Fernandez, what do you think?
There's probably four things that we benefit from the enterprise space, and that's their attention currently on big data / Hadoop. They're pushing that development pretty hard. And I'm going to say politically correct accelerators. The development of those, the adoption of those is something that we're inheriting in the HPC space, not necessarily driving it. Business analytics is also something that is coming into the HPC space. And to your point, Addison, if we go looking for HPC, it will be a niche. But if we go looking to solve problems and the solution happens to be HPC, then if we keep our mouths shut, we'll make some sales and make some money. I disagree with Marc Hamilton on the power and cooling. We're actually seeing HPC influenced by the demands of our enterprise customers, particularly the larger ones. And so their forced advancement on the power and cooling is being inherited in our HPC products.
Steve, the vendors are talking about all the great technologies you're getting from the enterprise data center. What do you think? Are you buying it?
Partially. So on the hardware side, HPC centers could learn a lot operationally from commercial data centers in the area of more formalized business practices. I'm not going to say you should adopt ITIL or Lean 6 or whatever, but you might look at that and compare how you run an HPC center and identify the gaps. Because if you're running a real business, you can't be down for extended periods, so you need to make plans for that. And we don't always see that in some HPC operations. In the software side, personally, I'm a cowboy. You know, I was called an individual contributor, but in
That's why you're on this panel, Steve.
In commercial software development, you know, there's a lot to be said for having more formalized development practices, especially since I'm not doing development as my main day job. But I was at a meeting a couple weeks ago where the people working on a code didn't know what unit testing was. So there's something to be said for having more formalized software development processes as used in industry to improve software quality.
Merle, what do you think?
I think the overlap helps us get better on-ramps. And we in the HPC business have been concentrating on the solver for so long, we've forgotten what the pre-processing challenge is all about. We put a purpose-built machine on the floor at NCSA, and we populated it with Dell nodes that were not deployed previously in the HPC space. They've been in the enterprise space. They screen. They do a really great job, but it was not on the normal radar for what we would have built. So we benefit from their play in this broader enterprise space. I think there's also overlap in the CIO community, the CTO community corporately. As this HPC IT enterprise kind of gets a little muddy, we all benefit because it's a bigger play than it otherwise would be.
Marc Hamilton, I got time enough to go back to you really quick. As $26 billion market is HPC, is it realistic to have products that are specifically developed for HPC in mind, or is that not a big enough opportunity?
Absolutely, we think it's big enough.
Marc Fernandez, where do you design for HPC here?
Agreed. It's big enough, and we continue to do that. We inherit and leverage from the enterprise whenever and wherever. May I respond to a key point Steve brought up?
Sure can.
One thing we have not picked up from the enterprise has to do with what would generically be called service level agreements. Your uptime requirements, your repair times, your turnarounds, etc. The enterprise does that totally different than the government does, and it's a whole lot less expensive. And the government just can't get rid of those T's and C's in order to achieve their perceived mission in that space.
Traditional measurements of reliability are getting outmoded in HPC ever since the transition to clusters. The most important overlap is in designing technologies that have efficient performance at scale. And then you're going to have to change the language of how you describe those in enterprise data center versus HPC. Our third topic keeps with the international theme of this year's HPCC conference. We were just talking about government initiatives at the low end. Meanwhile, Asia presently has 3 out of the top 5 systems, the top 500. There's several 10 petaflop systems coming online in the U.S. this year. The European Commission has announced a new focus on supercomputing. We had a talk on Russia, mentions of India. Is international competition in supercomputing increasing, and should it be, Steve?
Yes, international competition is increasing. It's pretty obvious. We heard references to various countries or European Union multi-year plans, whereas in the U.S. We do a year-by-year budget on a federal level, And even if you discount the relative quality of what you get for your money, you know, $80 million or $73 million next year's budget for exascale versus $1.6 billion EU budget, you can't compete on the relative financial scale. So we need a coordinated investment to compete, assuming that all dollars were spent equally well.
Merle?
Competition is a good thing. It breeds additional capability. There is competition country to country, government to government. But what I'd like to share is certainly with the global companies, and the use case is this is a shared problem. All global companies that want to make stuff in whatever country they choose, actually everybody needs this. The auto industry in Europe, the auto industry here, the auto industry in China, all needs better modeling and simulation. Do we want to fly better planes, safer? Mm-hmm. You bet we do. And I don't want we all want that. So there's a in the university community a way to actually play nice and work together to raise all boats, and we've not played that card really well over time, but we do talk, and that helps. So it reduces the competition, but helps raise all boats.
Marc, Fernandez, I mean, this comes back around to what I was starting to say before. You're a multinational company, same as a lot of these. What do you think about the international competition in supercomputing, and where do you sit with that?
I have a bit of a different perception on that. It certainly does exist. The other companies, Brazil, Russia, India, and China, are benefiting from 2020 hindsight. They've got green fields. They've got some pretty mature technology. So it is easy for them to, quote unquote, catch up. And the playing field will be much more level in the coming years. And so, as you say, that's when the true competition globally will take place, rather than between the Department of Energy and the Department of Defense, NASA on the east, NASA on the west. It will be a global competition. I look forward to that.
Marc Hamilton.
So I agree that international competition is good. I think that certainly if you look at what has driven the advancements in Asia and Europe, it has been that international competition. Competition drives innovation, right? And so different people are innovating in different ways, and I think it's not just about how do you spend the most money. If you look at some of the top 5 systems have been done very affordably, right, and driven some of the advances along accelerators, as I guess we're supposed to call them now. But I also think collaboration is important, right? And through that university environment is a great way that we can have collaboration. I think it exists today. There's certainly room for improvement, but I think where we have collaboration and competition is good.
Well, so a lot of these major initiatives are contrary to our survey data that shows that budget expectations among government and academia right now worldwide are at a 5-year low, right? So how do you see this dynamic changing between countries over the next 2 to 5 years?
I think that people really are forced to innovate, right? It's not just throwing, more x86 CPUs, right? It's looking at the software innovation, it's looking at the applications, it's looking at new power efficient technologies, whether it's accelerators or extremely power efficient chips like ARM or other chips at the low end, and people are exploring how can you do more with less.
Marc?
Yeah, I have great faith in America and America's innovative technologies, and the list that you've just presented is excellent. It's on our plate. We're looking at all that, and I think we're going to be okay.
Steve, the U.S. role evolving here. Are we catching up?
Oh, sure. I mean, I'm from the U.S. I hope we do well, but it is a global market. Every year, a different country's on the top of the top 500, so there's an ebb and flow. And I'm not counting us out.
Merle, you're all ready for blue waters here.
Blue waters will have a lot of derivative effects that will be beyond the hardware, and I think the hardware spend is easy to look at whether it goes up or down, but what bothers me is the lack of software spending. What we need to do is double down and spend twice as much on software than hardware.
First end user I've ever heard talking about wanting to spend more money on software. Congratulations. That's a first for me. With Europe in particular, I personally find it hard to believe that supercomputing expenditures are going to rise significantly over the next 2 years because of the Eurozone crisis. You know, the European Commission initiative notwithstanding, I just don't see where that's coming from. But I'm happy to be proven wrong on that. I think Asia is going to continue to rise over the next 2 years as a share of the market. Now, thanks for your in-depth insights. Those were the long answer formats. I hope you enjoyed those. We're going to hit a few more topics, going to your quicker opinions in the speed round. We've talked a lot about exascale the last few days. What aspect of exascale is most at risk or hardest to achieve by the end of this decade, Marc Fernandez?
Merle just hit it, and I'm going to say software scalability, and very carefully use those words. It's beyond application scalability. We've got to have OSs at scale, development environments at scale, etc.
Merle, what's the hardest aspect of exascale most at risk by the end of the decade?
The toughest thing to achieve here is a business model outside of DOE.
Really? The business model is the hardest one to achieve?
Yes.
Marc Hamilton.
I was originally a software developer way back, so I'll say software is easy. It is actually hard, but I think one of the tough mechanical or hardware problems is actually not in the chip design, but it's in power and cooling. Right? We have PhD plumbers now in our team, in effect.
Steve?
All right, I'm sticking with software, and I'm concerned about DOE having the leadership in this because they've publicly said they're willing to rewrite all their code, and they need to reduce their application development cycle from 8 to 10 years to every 4 years, and I need to defend the dustier decks a little on that. So
yeah,
software.
I get this point of view, and if we're talking about efficient use of exascale, I'm going to agree with you. We certainly don't have efficient use of petascale, barely terascale today. My prediction is by the end of this decade, maybe even 2018, we've got our first exaflop systems out there, and we're talking about, you know, if we're ever going to make it to zettaflops, we're going to need better investments in power, cooling, software, et cetera, et cetera. We've heard this song before. Big data, buzzword or big opportunity? Marc Hamilton.
Well, I think Hadoop is like, Hadoop is to Java as MPI is to Fortran, right? And it's very low level.
Say it again.
Hadoop is to Java as MPI is to Fortran. It's a way to take the Java applications and distribute them. But it's too low level. It needs more software investment so that the average software developer can make use of it.
I'm not sure I understood the answer. Steve, is this an opportunity or not?
It's an opportunity to apply to scientific simulation because as they get larger, you can't look at every number, and so data analytics becomes important, whether it's opportunity for expanding the HPC market. I'm not a salesman, that's Marc's issue. But I think we can use data mining of scientific data.
I'm going to come back towards Marc Fernandez in search of a true answer to this question. Are you going to invest in this or not, Marc?
Of course it's an opportunity, and of course we're going to invest.
Okay. You've got at least 10 more seconds.
Actually, it is a buzzword, and until you dig down to what those particular people mean by that and the problem they're trying to solve, right now it is an entryway into discussing those problems and how to solve them.
Merle, what do you think?
Marc, it's not a buzzword. This is a real challenge, a real opportunity. We're going to build in the Blue Waters project 350 to 500 petabytes worth of data storage, and then we'll figure out how we actually, the demand is there. I've got clients, large companies, one that actually keeps 30 petabytes of data. And to have 350 or 500 at our place, that doesn't seem so big anymore. So how we deal with this data on the corporate side, the big user side, that's not just science, is needed, and it's needed yesterday.
I knew I could count on you, Merle. This is a huge opportunity, but the people who are doing it won't always think of it as HPC, but it will require a lot of deployment of HPC technologies. Last speed round question. I want you guys to start playing Analyst. There's a little thing I'm calling Dead or Alive this time around. Your first Dead or Alive question, Windows for HPC. Is that dead or alive? Marc Fernandez.
It's alive at the workstation level, at the low end, and as a entry door into cloud computing.
Merle, dead or alive, Windows?
It was before its time. It needs to be alive. It may be dead today, but at the workstation, it's absolutely needed.
Mark, dead or alive?
Alive. Watch Microsoft Azure Cloud.
Steve, dead or alive, Windows for HPC?
Alive for moving existing Windows apps to HPC, dead for actually trying to get someone to switch from Linux to Windows.
Oh, yeah.
Next one, we've been waiting on PNFS for a while. We heard Jeff's presentation yesterday. PNFS, dead or alive?
Code Blue.
Let's start with Merle this time.
Alive.
Marc Hamilton.
Dead.
Steve.
Alive later than I'd hoped for, but it's important to decouple storage from HPC acquisitions so we can mix and match with a standard.
Mark Fernandez, dead or alive on PNFS?
We're calling it Code Blue, waiting for the defibrillator to show up.
Programming in Fortran, dead or alive? Start down at the far end, Steve.
Oh, it's alive. I like to count starting at 1, not 0.
Marc Hamilton.
Alive, should be dead.
Merle.
It's alive. It's in the manufacturing space today. It'll
Mark
continue.
Fernandez.
I can write Fortran in any language.
Last one. Sun, or I should say Oracle servers in HPC, dead or alive? Marc Hamilton.
Contracts with my previous employer preclude me from answering that question.
Steve.
Spark's alive in Japanese machines. We could count the number of former employees in the room. Mark, Rich.
Merle, Sun in HPC, dead or alive?
Dead.
Mark Fernandez.
Dead.
All right. As we wrap up HPCC, the last question I like to go around with is what I call one up, one down all the time. I want each of you to tell me what's one thing that you're impressed with right now, and one winner column, and also one thing that's perhaps disappointing you expected something better. I'll start at the near end again. Mark Fernandez.
I'm impressed with the power and cooling that we're making in the HPC space. I'm disappointed in our confusion about cloud.
Why?
Again, it seems to be, no pun intended, a bit cloudy. A lot of people have a lot of...
Pun was completely intended, but keep going.
A lot of people have different impressions of it, and when you're discussing a cloud, you will sometimes hit the mark, and sometimes you'll have glazed over eyes because that's not what they were expecting.
Well, that's absolutely true. You're going to catch some users who are pro-cloud and some who aren't, and the trick for you is going to be to figure out how to build cloud into your HPC message without subsuming your entire HPC message under cloud, which is a mistake we've seen some people make before.
Correct.
One winner, one loser.
I'd say the one winner right now, I'm impressed with how the White House dialogue is around manufacturing and the things that manufacturers need to do. That anytime we can get conversation about that is a good day, and so that is the winner. Whether it's all on target yet or all technical enough, doesn't matter. We're having the conversation, so that's a clear winner.
I'll agree with you. Dialogue's on target. I wish we were seeing a little more actually being done, but go ahead, give me your flip side.
Agreed, but we didn't used to have the dialogue at all. So
good point.
It's a good start.
What's your flip side? What's your downer?
Flip side, the downer is the lack of funding for software, and I believe it's because we don't have a good centralized focus. Manufacturing helps give us a focus and a reason why we should invest, but manufacturers have not had that conversation together. They've been rather competitive, and the way Washington treats industry, the last time people came in and flew in on airplanes, they got beat up. So that's a sore point.
Marc Hamilton, one up, one down.
So up is accelerators in the generic sense, investment in it, open standards like open ACC emerging. Down, I'll add cloud, right? HPC applications or HPC centers had originally been some of the multi-tenant part of cloud with batch queuing systems, and they think it's the virtualization part that has maybe confused or muddied the market and kept HPC.
Steve, last word's yours.
All right. So I think having exascale be in the forefront is up for lifting all boats, so to speak, although I'm more interested in how it lifts the lower end. And down, I agree with Merle that the lack of focus on software, you could have your exascale or petascale machine, but your code's running at 1 or 2% of the theoretical peak, and you can take a picture of your senator next to it, but it's not fully utilizing the hardware.
Thank you, panelists. That wraps up the HPCC 2012 edition of Analyst Crossfire. I'd like to invite our audience to look for Analyst Crossfire again at the conclusion of the ISC conference from Hamburg in June, and of course Supercomputing 2012 in Salt Lake City, where I'll be joined by other panels of experts on new sets of HPC topics. I'd like to again thank my panelists, Marc Hamilton, Marc Fernandez, Merle Giles, Steve Finn, for joining me and sharing their insights, as well as John West, John Miguel, and the rest of the organizers for another successful HPCC conference. For Analyst Crossfire, I'm Addison Snell, Intersect360 Research. Thank you.